Hi, in previous lecture I discussed quicksort difference with mergesort, and how we'll do the partition. We'll consider two pointers. One is I that will move from left to right, another is j that will move from right to left. We'll consider first element as pivot, and I will stop at a point where it will find a element that is greater than pivot, and j will stop at a element where it find that a of j is less than pivot. If I is not cross j, we can simply swap a of I with a of j. If I already crossed j, then we will swap pivot with a of j. If I equals to j, then we'll swap pivot with a of j. These three situations can arise. Let's discuss the partition algorithm. It's developed by scientist Hoare. So algorithm name is HoarePartition, ALR. L for left, R for right. We'll partition an array by using Hoare's algorithm. Using the first element as pivot, we can consider any element as pivot, but this algorithm describes about first element. We can modify according to other element as pivot. Then what is input? One array defined by its left as L and right as R. Then what will be output? It will partition A, L to R with the split position. So partition algorithm will return the split position. Then again we'll do quicksort of before the split position and after the split position, or left subarray and right subarray. Let's consider pivot as A of L, that is our first element. Then I equals to L and j equals to R plus 1. So I will be our left element or index 0 and j will be index n. Then we'll start the loop, repeat I equals to I plus 1 until a of I greater than equals to p. Suppose we find a element that is less than p, we'll skip and will continue. I will increase the I value till we find a element that is greater than or equals to p. So I will stop at that point. Then we'll repeat j equals to j minus 1. J will decrease until it find a element a of j that is less than equals to pivot. Our partition algorithm aim is will partition the algorithm in such a way that pivot will be in its position. Means after sorting, pivot will be in its position. So left part of pivot should be less than pivot and right part of pivot should be greater than pivot. That's why when we find a element that is greater than pivot, we'll stop, and when we find an element that is less than pivot, we'll stop. Then this comes under first situation. We'll simply swap a of I with a of j. If I is not cross j, we'll swap a of I with a of j. If I cross j, then we'll exit from the loop. So this loop will continue till I value greater than equals to j. So when I value is greater than equals to j, we'll exit from the loop and we'll swap pivot with a of j. What is pivot? A of L. So we'll swap a of left element with a of j and we'll return j. J is the split position. So before a of j all are less than a of j and after a of j all are greater than a of j. So now this a of j is already sorted. That is the position for our pivot. Let's discuss an example. These are the index starting from 0 till 7. So this is our L, this is our R. L for left, R for right, and we'll consider first element as pivot. So pivot is 5 and I will start from L, so I will be here, and j will start from R plus 1, so let j is here. Let j equals to 8. Now I'll continue the loop. I will be I plus 1. So next new I will be here and it will check is a of I greater than pivot. Is 3 greater than pivot? No. Then I value will increase. Now I will be 2. Is 1 greater than 5? No. then I will be increased. Now I is 3. Is 9 greater than 5? Yes. So I will stop here. Next will decrease j. So j will be j minus 1. Now j is here. Is 7 less than 5? No. Then j will decrease. Is 4 less than 5? Yes. Now we stop at 3 and 6. I is 3 and j is 6. I is not crossed over j. So what we will do is simply swap these two elements. As I is less than j, I value is 3 and j value is 6. 3 is less than 6, so we will swap a of I with a of j, means 9 will come here and 4 will come here. So let's swap 4 and 9. After swapping, we got this. Again, I value increase. Now, is this 8 greater than 5? Yes, so I will stop here and j value will decrease. Is this 2 less than 5? Yes, so j will stop here. Now I is not crossed j. So again I value is less than j. I value is 4, j value is 5. 4 is less than 5. So we can swap a of I with a of j. These two elements will swap. Now 2 come here and 8 come here. Again I will increase. Now I will stop here as 8 greater than 5 and j will decrease. J will stop here as 2 is less than 5. I will check every time is any element greater than pivot and j will check every time is any element less than pivot. Now I crossed over j. I value is not less than j. So I'll exit from the loop and we'll swap a of L, we'll swap pivot with a of j. Means we'll swap these two. 2 will come at 5 position and 5 will come at 2 position. So after swapping we got this. Now 5 is already at its position, it is already sorted. We found the sorting position of pivot. Now left side elements are less than 5, right side elements are greater than 5 and 5 is already sorted. So in this partition process we are also doing the sorting. In merge sort at the combine phase we are doing the sorting, while in quicksort at the divide phase we are doing the sorting. Next we will do for this left part, we'll again call quicksort 0 to index 3. Now what is pivot? Pivot is 2i equals to 0, j equals to 4 as r plus 1. This is our L, this is our new r. Now I value will increase and it will check is 3 greater than 2? Yes, I will stop here and here j will decrease and is 4 less than pivot? No. Again j will decrease. Is 1 less than pivot? Yes, so j will stop here. Next what we will do is simply swap a of I with a of j, as I value is 1, j value is 2 and 1 is less than 2. So let's swap 3 and 1. So we just swap 3 and 1 position. Now I value will increase, so I will stop here as 3 is greater than 2 and j value will decrease and j will stop here as 1 is less than 2. Now I cross j, or you can say I value is greater than j, so we'll exit from the loop and we'll swap pivot with a of j. So we'll swap 2 with 1. Now this 2 is already sorted. Left side just one element is there, so automatically it is sorted. Now 1 is sorted. Right side there are 3 and 4. Let's consider 3 as pivot. I is here, j is here. Now I will be I plus 1, so I will come here as 4 value is greater than 3 and j will be j minus 1. Is 4 less than 3? No. Then j will again j minus 1. Now a of j equals to pivot. So I cross j will exit from the loop. We'll swap a of L with j, means we'll simply swap 3 with itself. we are swapping pivot with A of j. Now pivot and A of j are same position, so we'll swap 3 with itself. Now 3 is sorted and just one element is there, so no need to do quick sort, it is already sorted. Now 5 left part is sorted. Next we'll do quick sort on right part. So this is our pivot, this is our L, this is our R. I index start from here from 5, j index start from 8. I will be I plus 1. Now new I position will be here. So is 9 greater than 8? Yes, I will stop here. Then j will be decrease. So j will come here. Is 7 less than 8? Yes. So j will stop here. I didn't cross j. I value is 6, j value is 7. I is less than j. So I will swap a of I with a of j. Means we'll swap 9 and 7 position. 9 will come here and 7 will come here. Then again I value will increase. So I was 6, now I will be 7. Is 9 greater than 8? So I will stop here. Next, j value will decrease. J come here. Is 7 less than 8? Yes, so j will stop here. Now I cross j. So we'll exit from the loop and we'll do swap of pivot with a of j. Means these two elements will swap. 7 will come at 8 position, 8 will go at 7 position. Now this 8 is already sorted. Before 8 there is just one element, so it is already sorted. After that there is just one element, it is sorted. So we did quick sort on this array. Now this array is sorted. 1, 2, 3, 4, 5, 7, 8, 9. Let me create a recursive tree for this example. Initially L is 0, R is 7, that is the index of left and right, and we split at position 4. So S equals to 4. Means after doing partition and this we return j value equals to 4. We return split position equals to 4. Next we'll do for left part, means L will be 0 and R will be 3. And after doing partition we got split position as 1. And for right part, left is 5, R is 7, and we got the split position as 6. Now after split position 1, at left there is just one element, so don't need to do partition. L is 0, R is 0, and at right side there are two elements, means L2 and R3. After doing partition we got split position as 2. For 3 split position is 2. Then at right side, before split position 6 there is just one element, right side there is just one element, so don't need to do partition, it is already sorted. When there is one element, that is already sorted. Now don't need to do split for this sub array, just check this. So after split position 2, at left side there is no element. From 2 element we did partition at split position 2. So at right side there is just one element, means L3 and R3 at right side. As there is just one element, we don't need to split. Now this is the recursive tree of Quicksort for this example. Now what is the height? Height is 3. Here we are not doing any split. This is just one element. So we are not calling recursively. Here just one element, here just one element, here just one element. So we are doing partition here, 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 here. So height is 3. If we take log 8, it is 3. So height we got 3. And there are 8 elements, so you can say running time is 8 log 8, or you can say n log n. N for n element, log n height of the recursive tree. In next lecture, I will discuss details about running time, what are the best case partition, what are the worst case partition, best case running time, worst case running time, average case running time. If this lecture is helpful for you, please like and subscribe. Thank you.